With GCP, clients send requests to the load balancer and it routes them to instances grouped by service. This time, the load balancer IP is global. Services can be placed in different regions for disaster recovery or high availability. The IP address is a single global virtual IP for all users. And the load balancer automatically terminates client connections in POPs closest to users. Then it routes requests to VMs nearest users for lower latency. This is known as Anycast with virtual IPs. There is also a target proxy to terminate incoming requests before deciding on which VM to route the request to. You can specify more than one IP address if you want users to access your application using more than one URL. For example, if running a test service or using HTTP and HTTPS. Each URL is specified by a virtual IP and port in a global forwarding rule. Each forwarding rule routes traffic by address, port, and protocol to a target proxy for session termination and rerouting to closest instances. Each rule supports a single port, so supporting HTTP and HTTPS requires 2 rules and 2 target proxies. Then target proxies start new sessions and route requests to backend services. Each backend service is comprised of a health check and one or more backends. Like target groups in AWS, backend services only send requests to healthy instances. VMs are still started and stopped by their instance groups, but instance groups may now receive messages from their backends telling them what to do. A backend consists of an instance group, a load balancing policy, and a capacity scaler. Scaling policies in instance groups may be defined by their backend policies and capacity scalers to distribute load across multiple instance groups. This isn't shown, but you would define another backend in the same service and associate another instance group with it. This is useful because instance groups are placed in zones and regions closest to end users. If capacity is exceeded by an instance group or no healthy instances are available, traffic is routed by the backend service to the next closest instance group. Note, a backend service may have up to 500 endpoints per zone. In addition, an HTTP load balancer can map URL paths to specific backend services, just like AWS did with listener rules and target groups. Here, the URL map on the right splits traffic for orders and inventory paths into 2 different backend services. A default URL map, shown on the left, is a single star path match routing all traffic to the default backend service. And each backend and instance group has one or more named ports it can communicate on. Like AWS, this lets you define path-based routing to specific microservices or containers that are often on different ports, and allows you to run multiple services on a single instance group by adding it to multiple backends and using both named ports. So to review, Compute Engine similar auto-scaling and load balancing capabilities and some key differences including faster spin-ups with less configuration in auto-scaling, a fully managed global load balancing service with a single IP, global disaster recovery, and high availability, geo-affinity, and no DNS load balancing needed. For more details, see the GCP for AWS Professionals document or the link here. Here is a high-level summary of the GCE terms we've introduced with their corresponding EC2 counterparts and scopes in blue. Now let's create an instance template with a web app on it, add it to an instance group that scales across a region, and put it behind a load balancer.